So let's just start. Okay, we have as a redox. Electrons gain and loss. Okay. Oxidation, reduction. Just a second. Let me add people. So oxidation, reduction, gain electrons, loss of electrons, balancing redox equations, everything. Okay, we did that, and we started off with trying to figure out how to make a I mean, kal we did this entire thing. Let me just give you a brief recap. That yesterday we just said that how do you know whether something is going to lose electrons or something is going to gain electrons? Sometimes you know, like sodium is very reactive, so you know that it likes to lose electrons, and it likes to lose electrons a lot. But then there are other substances, which copper 1+ ion, I don't know whether it wants to form copper 2+ or whether it wants to form copper, whether it wants to get oxidized, whether it wants to get reduced. I have no idea. So there are lots of compounds for which we have no idea what they're going to do. So in that case, you need a quantitative value, which can tell you what that substance likes to do and how much does it want to do that. If sodium wants to lose electrons, then exactly how much does it want to lose electrons? Does it want to lose electrons more than potassium or less than potassium? You need a value for that. Okay, so we did electrodes, and we did 3 types of electrodes. You make electrodes. The electrodes give you potential values, voltage potentials, which will tell you what it likes to do. For example, if you have sodium, the sodium ke case mein what you had was that sodium really likes to lose electrons. We already know that. So sodium will start forming sodium ions, and it will start to produce a lot of electrons. And the electrons will accumulate on the metallic rod. There's a delocalized electrons, and the sea of electrons, which is metallic rod hai. Just a second. So on the metallic rod, you'll have more and more electrons on the metallic rod because sodium would be losing a lot of electrons, and it will continue to lose electrons up till a certain point. There would be so many electrons over here, and the negative charge would become so large that the huge negative charge that has built up on the rod, the huge number of sea of electrons, they will start attracting the sodium ions back again, and that's when a reversible reaction sets up. But we know sodium likes to lose electrons, so there's going to be a lot of negative charge that's going to build up before that point comes. And you can measure the potential of that negative charge, which would come out to be minus 2.71 volts. That's given in the data booklet. And the negative value indicates, or the negative potential indicates, that the substance really likes to lose electrons. Okay, that's the first thing we did. And whenever you have a metal which is supposed to be in equilibrium with aqueous ions, you'll have a metallic electrode which would be made out of the same metal, and the ions would be part of the solution. Okay, so if I'm trying to investigate copper in equilibrium with its copper ions, okay, I'm going to do the same. I'm going to draw the same type of electrode. So if I do this reaction, can't pay with data booklet, just a second. So if I look at the data booklet, so remember, drawings are important. Drawings are very important. एक second, मैं question देख लूं. What's the? Yes, it's a simplified version. You can't immerse Na with aqueous solution. Actually, something similar is done, but it's not directly Na. I mean, there's certain. I mean, to make a sodium electrode. I mean, just for the sake of knowledge, okay? to make a sodium electrode, because sodium is so reactive that you're going to have an explosion otherwise, right? So I'll just show you. So how do you measure or construct a sodium? This thing. I'm just googling this. Most of the diagrams I'm making, they're very simplified versions, right? So standard electrode potential. So you obviously can't dip sodium directly into water. So the practical limitations are a lot. So instead, there's an amalgam that's made. It's not. I mean, it must be given over here. Just a second. यहाँ पे नहीं होगा. ठीक है, just for the sake of knowledge, it's. So what they do is they actually use very little sodium. So for example, over here, there's from measurements in the cell Na, the standard electrode potential. Just a second. Yep, this one. There's an amalgam of Na which only has actually 0.0651% of Na. So you're not actually dipping an electrode that's full of sodium, because that will lead to an explosion. So the cell actually, the electrode actually has very little sodium. You then extrapolate it. You measure the potential of that tiny bit of sodium, and then you try to figure out what would have happened if you had a huge piece of sodium. Is this clear? So remember all these diagrams, TK, you just have to know how to draw these diagrams, not the actual practical details. TK, they're not needed. TK, every electrode, just make the basic diagram, that's it. Acha, copper wala, this one. So I just wanted to show you that drawing is important, TK, label drawings. So here you can see this one over here, copper 2 plus, which is in equilibrium with copper. And the potential is given as it's given as 0.34 volts. So I was saying that if you have a metal, and if that metal is supposed to be in equilibrium with its copper ions or aqueous ions, then you're going to make this type of electrode, which we just did. You'll take the piece of copper. The electrode would be made out of copper. And the solution over here will have copper ions. And since it's going to be a standard electrode, it will have exactly 1 mole per dm cube of copper 2 plus ions. Okay, so make sure you use standard conditions. So the copper 2 plus ions will be 1 mole per dm cube. Now, whatever happens, whether it likes to lose electrons, if it likes to lose electrons, there's going to be a lot of electrons that's going to build up over here, and the potential on this electrode would be negative. If copper ions want to gain electrons, the electrode would become electron deficient, and it will have a positive charge. So whatever happens, the potential will appear on the voltmeter that's connected to it. And you can go and measure that. So you can go and just go home and measure that potential, that's it. So that's how you're going to do that. So that's the first type of electrode, which is a metal in equilibrium with its aqueous ions. And then we did this other one, which is, what if you have a gas in equilibrium with aqueous ions? You need a platinum electrode. You always mention when you're drawing the diagram in the paper, we'll do past paper questions. The Cl2 has to be at 1 atmosphere pressure. Standard conditions. So it's got to be at 1 atm pressure, and the concentration of the Cl ions in solution. So the concentration of Cl ions in solution, that's going to be it's going to be 1 mole per dm cube. और फिर इसी तरह you've got aqueous ions only, right? So in aqueous ions, both ions will be added to the solution. The concentration of all the ions will be 1 mole per dm cube if you want to measure the standard electrode. So Fe3 plus aqueous is going to have the same concentration as it's going to have the same concentration as Fe2 plus aqueous. And it's going to be 1 mole per dm cube as well. And you'll put a platinum electrode. So make sure you draw the drawings correctly. Make sure you label everything. The ions will be 1 mole per dm cube. Aqueous ions. So यहाँ पे ना you'll have all sorts of electrodes in the data booklet, and they'll fit either one of the descriptions, right? So for example, this one over here, Fe3 plus ions in equilibrium with Fe. That's a metal electrode, Fe electrode, and the solution will have Fe3 plus ions. If you have this one, fluorine in equilibrium with F minus 1, the F minus 1 will be part of the solution. The F2 will be a gas that will be present in a gas jar, and there's going to be a platinum electrode, so it's a gas aqueous ion electrode. This one over here, you've got a copper metal, so the copper metal will be the electrode. And ammonia and this ion over here, they would be part of the solution, and they will be 1 mole per dm cube. If you look at this electrode, copper 2 plus in equilibrium with copper plus 1, both ions will be added to the solution, 1 mole per dm cube. You'll insert a platinum electrode, and the potential on the platinum electrode will appear to be 0.15 volts. Okay? So just remember this, that so just remember that okay, I'll write these as you can pick any equations and they'll fit one of them. Okay, so you'll be asked to draw these electrodes. Is this clear? Okay, electrodes ki drawing, is that clear, this part? I said next thing is the important part or the key part. Okay, this is the summary of your entire chapter. Because remember, the whole chapter is about who gains electrons, who loses electrons, right? So now one thing is missing so far. Let me write the summary first. Higher potential. If something has a higher potential, high E naught, E naught is how the potentials are going to be measured. If there is no naught, that means it's not under standard conditions. That's it. So high E naught indicates that the substance likes to gain electrons. So it wants to gain electrons. And lower E naught, which is the negative potential, the substance likes to lose electrons. So you've got high E naughts and you've got lower E naughts. I mean, this is the main crux. Okay? Just fit this in your mind. Okay, if the potential is higher E naught, that means it wants to gain electrons. If it's a lower E naught, that means it likes to lose electrons. Okay? Why was sodium so negative? Why was it so low? Because sodium really wanted to lose electrons, and there was a lot of electrons, which is why the potential over here became very negatively charged. So lower E naught indicates that it really likes to lose electrons. And vice versa, high E naught, Cl2 जो था वो क्या कर रहा था? It was gaining all the electrons from the platinum electrode, because Cl2 really likes to gain electrons. So the platinum electrode became more and more positively charged. So a higher potential indicates that it wants to gain electrons. So this over here is the entire summary of the chapter. Okay, just before moving on, keep this in your mind. High E naught gains electrons, low E naught loses electrons. Okay, just make sure you memorize this. Okay, ये clear है? Shian, Haseeb, is this clear? Alicia, is this clear? And So one other thing is that potential, remember, is a relative term. Measurements, okay, whenever measurement is a relative term, actually, it's everything is relative to something. Whenever you try to measure something, it is measured against something. ठीक है, मतलब हवा में कोई चीज नहीं होती. Like if I say that something weighs 10 kg, that number 10 kg is a relative term. It's relative to a kg, right? What is a kg? There's no definition of a kg. It's just somebody picked a stone and said that it's a kg, right? So the kg itself is just a reference point. It's a reference point. Some countries use tones, some countries use pounds. I mean, ancient people had different relative weights. So the point is that measurement is always relative. If you say something is 10 kilometers, that's relative to a meter, because somebody defined that this is a meter, right? And then you started measuring everything against that meter. Some other people would measure it against yards, against feet. So remember, measurements is relative to something. Height is relative to something. Like if I say a building is 1,000 meters tall, right? So the question is, or if I say that a certain mountain has a height of 8,500 meters, right? The next question is relative to what? Like 8,500 meters from the sea, or 8,500 meters from the base of the mountain, or 8,500 meters from some other place. Like, so you need a reference point, right, for measurements. Now, similarly over here, your voltmeter is not going to function on its own. If it says that the voltage over here is 0.77 volts, that means the voltage is measured with respect to something. And that something is known as your reference point. You need a reference for that. The reference point itself is meaningless, because remember, if I measure the height of a mountain in feet, or whether I measure the height of a mountain meters or kilometers, it doesn't make a difference. The height is still the same, right? The tallest building will still be the tallest building. The smallest building will still be the smallest building. So the reference point is kind of irrelevant. You can pick any reference point and you can choose that, right? So when you measure voltage, the voltage has to be measured against something. Like if it's positive 0.77, positive compared to what? If sodium, I said, was negative 2.71 volts, like negative compared to what? Like you need a reference point, right? So what is our reference point? When I say that my electrodes are positive or my electrodes are negative, but compared to what? That's the question. Okay, so what is this thing? What is this reference point? What am I comparing the voltages with? Okay, so that something is basically an electrode. Every voltage is measured against a certain electrode. The reference point always has to be the same. Agar my weight, if I'm measuring the weight in kgs, I should always measure my weight in kgs, right? Like all the weights have to be measured in kgs, because only then will I be able to compare them, right? So the reference point has to be constant. Doesn't matter what the reference point is, but it has to be a constant reference point. In this case, it's an electrode. If you look at the data booklet, you'll notice that hydrogen over here, this one, has a voltage of 0, right? So that's basically a reference point. That's this is the electrode that is used as a reference. Reference ki khud ki jo value hoti hai, that's 0. Like if you're measuring the height of buildings from sea level is 0 meters then, because everything else will be taller than the sea level or lower than the sea level. So the reference point itself is going to have 0 voltage. Is that clear? The basic idea is every voltages, all these potentials are measured against a particular electrode. And all these electrodes are either going to be more positive than that or more negative compared to that. So नहीं वही स्पेसिफिक रीजन के रेफरेंस को मुझे बताओ कि if I'm choosing if I choose sea level as the reference point for measuring the heights of everything, the mountains and the buildings, right? So what is the height of the sea level? It's going to be zero, right? See, is that clear? क्योंकि सी लेवल को आप फिर किससे मेजर करोगे? सी लेवल you because you're using sea level as the reference, right? So how tall is or how high is the sea level compared to the sea level? It has the same height. There's no difference. It's zero difference, right? So if I choose hydrogen as the reference point, so I'm going to measure the voltage of hydrogen with respect to hydrogen. So the voltage difference would be zero, right? There would be no difference. Is it clear? So we're gonna talk about or draw the reference electrode. Which is known as the standard hydrogen electrode. So that's why if you remember the reactor series in IGCSE O levels as well, no reason. I mean, choosing hydrogen, there is absolutely no reason. You could have chosen someone else, some other electrode as well. The only point is if you choose a reference, then you have to keep that reference. If you're measuring the heights in meters, then everything has to be measured in meters. वो बीच में एक बंदा आके ना, if he starts measuring in feet, then it won't make sense. Like one building is 1,000 meters, the other one is 2,000 feet. That will just create confusion. So there is absolutely no reason. So the same way, like you measure all the mass of atoms with respect to carbon, right? There's no reason. I mean, there are obviously some reasons for that, but technical reasons maybe. Maybe it's very easy to set up the hydrogen electrode. That's why they, or the voltage of the hydrogen electrode is very stable. So that's why they chose that. I mean, there could be some technical or practical reasons for that. So standard hydrogen electrode. So I'm going to draw. You need to take me through. Okay, all electrode potentials are measured with respect to standard hydrogen electrode. Remember to write the full name. I mean, this is not the abbreviation. In the same way as the height of the sea level with respect to the sea level is, I mean, it is. I said, remember, that's another thing. That's another thing. Remember, potential is a relative term. Like if I say how tall or what is my height with respect to my height, I mean, there's no difference. Like how tall am I from myself? I mean, I'm 0 meters tall from myself, right? I mean, it's a reference point. Like, how tall am I from some other person? I might be taller than him. I might be shorter than him, right? So the point is that potential is itself a meaningless value. TK itself, the potential means nothing unless you compare it with something. TK, एक example कर लेते हैं. If in physics, like you have, let's say you have a resistor and there's 1,000 volts over here, and you got 0 volts on this side, right? So what is the potential difference across this resistor? That's 1,000 volts, right? Now, what if I take another resistor and there is minus 500 volts potential on this side and there is plus 500 volts potential on this side, right? So what is the potential difference across this resistor? It's exactly the same. It's 1,000 volts. So the point is potential is a relative term. Okay, almost all measurements are relative to something. So when I say that sea level has a height of 0 meters, that I mean sea level has a height maybe compared to something else. But if you're comparing sea level with sea level, then it's obviously, if the reference point is the sea level, then it's obviously 0 meters. Okay? So hydrogen is 0 volts. But coming back to this, just to clear the confusion, hydrogen is 0 volts, right? But if I compare it with this other one, the one at the bottom, right, it's minus 0.83 volts. So hydrogen has a higher potential compared to this one. Alicia, do you get the point? Isliye I use the word higher and lower, right? It's not because this zero is meaningless. It doesn't signify anything. Okay, but if you compare it with minus 0.83, then hydrogen electrode obviously has a higher potential compared to minus 0.83. Is this clear? So because remember, this is important. So if somebody tells you that something is 10 volts, this information is completely meaningless, because 10 volts, if somebody tells you that, like, I have a pen and there's a potential of 10 volts on this pen, right? This information is completely meaningless. I don't know, is that a higher potential or is that a lower potential, and compared to what? Like, what do I do? I mean, that information is completely meaningless unless I compare it with something. If somebody tells me that this has a 10 volt potential, or it has a potential difference of 10 volts compared to something else, then that has some information in it. So your value and this value itself is meaningless unless you compare it with something. So coming back to this, so remember, the value of the potential is meaningless. Okay, as long as you make a comparison. Okay, as long as you compare it with something. That's why they use the word potential difference. Okay, the difference is important. So coming back to this hydrogen electrode, so I'm going to try and measure and complete the drawing now. Okay, so I had this electrode. I'm going to copy this electrode, and I'm going to make a full electrode now. Okay, so the previous diagrams that I did would not complete. Because wo jo reference wala part na, that was missing actually. So I'm going to complete this now. So I'm going to add the standard hydrogen electrode now to this. And the standard hydrogen electrode would be, it's going to have a platinum electrode. There's going to be H+1 ions in the solution. And the concentration will be 1 mole per dm cube. And they would be in equilibrium with hydrogen gas. So the hydrogen gas will be in a gas jar at a pressure of 1 atmosphere. So that's at 1 atm. And what else? And we'll have a platinum electrode. So we'll have a platinum electrode. Now my diagram is complete. So that's your standard hydrogen electrode on this side. So all electrodes are going to be measured. Any random electrode, its voltage would be measured with respect to the standard hydrogen electrode. Okay, every time you're going to draw this as well. Is this clear? You clear? So in the data booklet, this is 0 volts and this is 0.77 volts. Basically, you get a positive voltage on the when you measure the potential difference of the iron ion electrode compared to this. As a last is there's one thing that's missing, and that one thing is a salt bridge. Okay, remember you're going to get a 5-mark question, 4-5 mark question on just drawing this. ठीक है वो बाकी बातें तो बाद में just the drawing, that's a 4-5 mark question. So you're going to have make sure to add the salt bridge every time. Okay, so that's how your electrode would look like. Hydrogen electrode, and that's the electrode that you're trying to measure the potential of. Okay, and every time ये जितने भी ऊपर बनाए थे ना, every time all of these, the reference point is a standard hydrogen electrode. Every potential is going to be measured with respect to. So over here, there's going to be a standard hydrogen electrode. As a salt bridge, I said let's do salt bridge in the next class. Okay, this one now opens the whole thing up because now it's an electrochemical cell. Okay, so you have one electrode and you have another electrode, but we'll have to discuss that in a lot more detail in the next class then. Abhi what come time hai. Abhi just stick to the drawing part. Okay, and we'll discuss salt bridge. Why is it necessary? And we'll also discuss what's going to happen if you connect an electrode with another electrode. Because now there's going to be a flow of current. This is known as an electrochemical cell. It's no longer an electrode. Electrode jo tha na, ye tha khali. This was an electrode, but when you connect two electrodes together, now a current will flow. Current always flows from, or the electrons flow towards the lower potential. So from the positive potential, they're going to start flowing towards the negative potential. But that's we'll discuss this in a lot more detail in the next class. So stick to this. This is the complete diagram that you're going to draw for any electrode. Remember, there are 3 types of electrodes. All the equations in the data booklet can either fit one of the electrodes. It's either metal with an aqueous sign, or it's a gas in equilibrium with aqueous signs, or you'll have electrodes that only have aqueous signs in them. Okay, so there'll be 3 main types of electrodes. And every time you measure the potential has to be measured with respect to the standard hydrogen electrode. So every time it's going to be measured with respect to the standard hydrogen electrode. Okay, is the diagram clear? Remember, diagram is important. That's why we're spending time on this. Okay, this thing. Rest we'll talk tomorrow.
Sir?
Yes.
Will a hydrogen electrode always be part of this whole thing?
Part of?
Part of this electrolytic cell.
Because remember, one thing is that if you're measuring the potential, right, then the potential has to be measured with respect to the standard hydrogen electrode. Is that clear?
Yeah.
But remember, in reality, you can connect any 2 electrodes together. There's nothing wrong with that. Like if you're measuring the potential, the standard potential, then the potential of the electrode has to be measured with respect to the standard hydrogen electrode. Okay?
Okay.
Or मतलब अगर आप measurement नहीं करें तो you can connect any 2 electrodes together. There's no, but we'll talk in detail about that. Okay? Make sure you get the diagram right. So let's talk tomorrow. Okay? We'll discuss what's going to happen now when you have 2 electrodes and they're connected together. We'll discuss what does the salt bridge do and everything else. Okay? So लेकिन ये याद रखना ये वाली चीज. High inert gains electrons. Lower inert likes to lose electrons. Remember that. Keep this in mind. This is the whole topic. Okay? So okay, everyone. नहीं ये notes तो updated है ये so ये not I won't be able to upload them right now. It's I can share the link with you. Just 1 second. I'll post it in the group. इसको और open this on your laptop. It won't open. ठीक है, it won't open on your phone. Most likely, it won't open on your phone. चलो ठीक है, okay everyone. हाफिज़.